So today we're going to examine two new tools that you can use to solve for derivatives. The first one is the product rule and the second one is the quotient rule. Now we use the product rule when we are given a function following the format f of x times g of x, and we use the quotient rule when we are given a function following the format f of x over g of x.
The product rule. Why we use it. We use the product rule in order to find the derivative of two factors that have been multiplied by one another. An example is shown below. Now you may think you can find the derivative of each factor and then just simply multiply them by one another. However, this is not correct and you will not get the right answer. The wrong way to do it is shown below, and make sure you do not do this. Instead, you're going to have to use the product rule in order to find the derivative of these types of functions. Here's the general formula for the product rule. What you're going to do is first start off with your factor f of x and g of x. You are going to put these side by side by one another and then write the derivative under it as shown below. You will then multiply diagonally f prime of x times g of x and then add multiplying f of x times g prime of x. This will give you the derivative of your function that you're trying to find using the product rule.
Okay, so here we have the first example of the product rule, which is we have the equation 3 minus x squared times x plus 4, and you're going to take the derivative of each and then multiply across like so. So we have negative 2x times x plus 4, and then we're going to add that to 3 minus x squared times 1. So on the left side, you get negative 2x squared minus 8.
Sorry, I'm at 8x.
Plus 3 minus x squared. And then you're just going to combine like terms, which will give us the final answer of negative 3x squared minus 8x plus 3. So here we have the second product example. We have x squared times sine of x. And so we're going to write our two factors and write the derivatives. So derivative of sine is cosine, and derivative of x squared is 2x. And then we're going to multiply across, so 2x times sine of x and x squared times cosine of x. And we're going to add those together. And that will be our final answer because there's no combining like terms or simplifying.
Here is the product rule example number 3. So you're going to take the derivative of 3x plus 1 to the 4th times 2x minus 1 to the 5th. You're going to start by writing the factors down below, and then in order to find the derivative of these two factors, you need to do the chain rule. So quickly do the chain rule off to the side. Here is it shown below. Once you have the answer to that derivative of the factor, you will then place it below in your chart like it is shown here. 12 times 3x plus 1 cubed. You're going to do the same for 2x minus 1 to the 5th. Start by doing the chain rule, and once you find the derivative, place it underneath in the chart. Now you will complete the product rule by multiplying diagonally 2x minus 1 to the 5th times 12 times 3x plus 1 cubed, and add that with 3x plus 1 to the 4th times 10 times 2x minus 1 to the 4th. And there is your derivative. The answer is being written below.
When you are given a function that follows the format f of x over g of x, you can find the derivative using the quotient rule. To do this, you are going to use a chart. You're going to write out f of x and g of x side by side, and then write the derivative of those right below them, f prime of x and g prime of x. Then you are going to multiply up and diagonally f prime of x times g of x, and this will be the first term in the numerator. Then you will multiply down f of x times g prime of x, and you will subtract this from the first part. Then to finish it off, you will square g of x and put this in the denominator to get your general solution for the quotient rule.
All right, so here's the first example for the quotient rule. So the problem is 6x squared divided by 2 minus x. And then the top function is f of x and the bottom function is g of x. So I'm writing out f of x is equal to 6x squared. And then I take the derivative f prime of x, which is equal to 12x. And then g of x is equal to 2 minus x. And taking the derivative g prime of x, it's equal to negative 1. And now we're going to use the quotient rule formula. So I'm going to multiply f prime of x and g of x. And then I'm going to subtract f prime of x times g of x. Or f prime of x times g of x minus f of x times g prime of x. And then all over g of x squared. And now I'm going to simplify and combine like terms. So first off is to multiply 12x and 2 minus x. And then I'm going to multiply 6x and negative 1. And then multiply it by negative sign since there's a negative sign in front of that. And that is my final answer once simplified. Alright, so the problem is 3x plus x to the fourth divided by 2x squared plus 1. So f of x is equal to 3x plus x to the fourth, and f prime of x is equal to 3x plus 4x to the third. G of x is equal to 2x squared plus 1, and g prime of x is equal to 4x. Now we're going to use the formula for the quotient rule. So you're going to multiply f prime of x and g of x. And then you're going to multiply f of x and g prime of x. And then you subtract f of x times g prime of x from f prime of x times g of x. And then it's all over g of x squared. So that's 2x squared plus 1 squared. And then I did a multiplication box right there to multiply the terms 3 plus 4x to the third times 2x squared plus 1. So that's the problem simplified out right there. And then I'm going to multiply negative 4x times 3x plus x to the fourth. All over 2x squared plus 1 all squared. So distributing the 4x, or the negative 4x, between the terms 3x plus x to the fourth gives us negative 12x squared minus 4x to the fifth. So now we're going to simplify it with the terms from the earlier multiplication equation, or multiplication problem for 3 plus 4x to the third times 2x squared plus 1 to get our final answer on the top. So simplifying like terms, we get the answer 4x to the fifth plus 4x to the third minus 6x squared plus 3 all over 2x squared plus 1 squared.
For the third example for the quotient rule, we have the function sine of 4x plus 6 over 6x squared minus 3. So we're going to start off by writing off the chart, sine of 4x plus 6, and next to it 6x squared minus 3. Then we're going to take the derivative. This one is a simple chain rule. You take out the inside function derivative and multiply it by the derivative of the outer function, and you get 4 cosine of 4x plus 6. And then for the derivative of 6x squared minus 3, you just get 12x. First, you're going to multiply up, and you're going to get 6x squared minus 3, and multiply that whole thing by 4 cosine of 4x plus 6. Then you're going to subtract multiplying down, which is 12x times sine of 4x plus 6. Then you're going to square the denominator, which will be 6x squared minus 3, all squared. Then, just to clean it up a little bit, we're going to simplify the numerator by distributing the first term. You're going to distribute this by just multiplying, and for the final derivative of this, you're going to get 24x squared minus 12 times cosine of 4x plus 6 minus 12x sine 4x plus 6, all of that over 6x squared minus 3 squared. And there you have it. That's the product rule and the quotient rule. Now you're ready to go out and start practicing problems on your own.